Hi, here we are in section 2.3 and we're looking at derivatives of natural logarithmic functions. Now we already looked at how a natural log uh, graph looks like. Let's take a look at two formulas that you will need to know. And remember, we derive these formulas by, so first of all, this is the function that we are talking about, y equal ln of x. And the ln of x, when you have a single variable x, or sometimes you can have a complicated expression, ln of something, like x squared plus 5, or something similar, but it's an expression. First, let's take a look. What I was trying to say is, how do we arrive at the derivative of these functions? Well, we take a quotient rule, apply quotient rule to these functions, and then we take limit as h goes to 0. And so you know how to arrive. You can do it yourself. Look at in a textbook. There are steps procedures are shown to you. But then once you carry your calculations, you will find the derivative of ln of x is 1 over x for all x greater than 0. That's this first formula. So derivative of ln of x equals to 1 over x. Now the second one is when we have something more complicated inside ln. So in other words, there's a function embedded inside ln. So then we apply a chain rule. Chain rule tells you that derivative or ln of function of x will be 1 over function of x times the derivative of function of x. Another way of write this also, you will see often is written in this way. But it basically, these two are the same, they're equivalent. Okay, so you need to memorize these formulas or use them until you internalize them. So let's take a look at the examples. The first one, we're just gonna work with the first part of the formula, derivative of simple y equals ln of x, and then of course we will progress to something a little more complicated. All right, so first one, I have y equals 5 times ln of x. So constant, you remember how we treat constant. So y prime, we're going to leave constant alone, and then derivative of ln of x is 1 over x, which we can write as 5 over x. Okay, let's take a look on the second B example. You have y equals x. Let's do x cubed ln of x plus 4x. Okay, this is good. So I just want to point out that the first part of this expression is product. I have x cubed and ln of x. So what we're going to do, and then the second one is just, it's very simple term. Okay, so what are we going to do when I'm finding derivative? I'm going to apply the product rule. So it's the first item, x cubed, times the derivative of the second item, right? I'm just going to put prime to make a derivative, then plus ln of x times derivative of the first factor, and then plus. So I just applied, this is the product rule done, well, almost completed. It's just a sketch of what's going to be, and then I'm going to take in derivative of that last term. That's not part of the product rule. It's just take a derivative of that. All right. Now let's continue. So it's x cubed. Remember, I'm going to multiply it times 1 over x, which is derivative of ln of x, plus ln of x times 3x squared plus 4, and simplify just a little bit here. So for instance, I can cancel this and this. 1x is gonna go out. Let's see what else can I do. Not much. Okay, so y prime is equal to x squared plus, and I'm gonna change the order here. I'm gonna put plus 3x squared ln of x, so so for clarity, and then plus 4, and that's all you can do. This is our final answer. And here's our third example, C. Okay, so you recognize it as a quotient, and I could apply quotient rule, or I can think of this as y equals ln of x times x to the negative 2. We could do the product rule, but let's go over quotient rule so we are comfortable with that as well. Okay, so then y prime is gonna equal denominator. Okay, just copy it, then ln of x prime minus ln of x times x squared prime over x squared squared. Okay, and here we go. So we have x squared times ln of x, derivative is 1 over x, then minus ln of x, and derivative of the x squared is 2x. Then make sure you don't multiply this ln of x times 2x, like this x and this x are, remember this is inside the function ln, so you cannot, absolutely cannot multiply them. Okay, just want to make sure that you guys know this. All right, simplifying this first part, it gives me just x because I'm canceling. I have two x's in the numerator and one denominator. So y prime equals, oops, I forgot to write a denominator. All right, it's x4. Okay, and let me erase this and start here a little lower. Y prime equals, it's x minus, and I will bring this in front so it's not confusing. It's gonna be minus 2x ln of x over x to the power of 4. I can do one more step. I notice that I have x here and x here, and we can factor it out. So x times 1 minus 2 ln of x, okay, divided by x times x cubed, that's x to the power 4. And as you can see, I can cancel this and this, and my final answer is going to be a little more simplified, or completely simplified. 1 minus 2 ln of x over x cubed. And that's all for this one. It's our final answer. Let's take a look at the next example. We need to differentiate y equals ln of 3x. This is where you apply chain rule. Just remember that we have not just variable x, we have something along with it. So y prime is going to be, and it's going to be 1 over 3x times derivative of 3x prime, which gives us 3 over 3x, cancel, cancel that, gives us 1 over x. Okay, let's take a look at another example. B, y equals, let's do ln of x squared minus 5. Again, this you need to apply chain rule, and here we go. Y prime equals 1 over that expression x squared minus 5 times that expression prime. Okay, and continue with this. You have, so I'm doing the numerator here. The derivative of this x squared minus 5 is 2x, and denominator is just copy x squared minus 5. And that's all you can do. That's our final answer. You cannot cancel x's here because you don't have x in another term, so that's that. And here's another example, differentiate. Oops. Differentiate the following. F of x equals ln of x. Again, we have function embedded inside of ln. So the derivative, chain rule, we apply chain rule, and derivative of f of x is going to be 1 over whatever you had in parentheses, that's ln of x, times the derivative of whatever was inside the parentheses. So f prime of x is equal to 1 over ln of x, and derivative of ln of x is 1 over x. So we can put this together as 1 over x ln of x, just in the proper form or proper order, and that's our final answer. Alright, let's take a look at the next example. F of x equals ln of x cubed plus 4 over x. So obviously we have a function embedded inside, and that function is happen to be a fractional function. That's okay. So let's take a look. We are gonna use chain rule. So our process, f prime of x equals 1 over whatever we had um, in that parentheses, 1 over x cubed plus 4 over 4, we'll talk about it in just a second, times x cubed plus 4 over x prime. Okay, so let's take a look. When we are doing 1 over the fraction, that means we can flip it over. So that gives us 4. Ooh, I see, I copied things incorrectly. So pardon me. I see my errors, the copying error. It should be here over x, not over 4. So let me do this. Okay, now I am gonna, when I'm doing 1 over this function, that means it's x over x cubed plus 4, and then I'm gonna multiply this times the derivative of this. So derivative of that, it's gonna be a quotient rule here. So I'm gonna put bracket here, so I'm gonna have x times x cubed plus 4 prime minus x cubed plus 4 times x prime. That's our numerator. Denominator is our x squared. Okay, and just taking one step at a time, let's go ahead and so I have x over x cubed plus 4 times, again, what I have here is x, and I'm doing derivative of this right now, so that gives me times 3x squared times 0 for 4, and that's times 0 plus 0. Okay, so it's that term is gone. Then I have minus the derivative of this last term of x is equal to 1, so it really doesn't play any role. So I'm gonna just distribute this negative, and so I get negative x cubed minus 4, and I guess I can combine these. It's gonna give me 3x cubed here, just so we are not mixing up with the first expression. All right, then denominator is just x squared. Okay, let's clean it up just a bit. All right, so what I have here, I have a numerator, I have x times 3x cubed minus x cubed minus 4, and denominator I have x cubed plus 4 times x squared. I can see that this x and this, I have x times x, will cancel one of the x's. And let's see what else can we do. Okay, f prime of x is equal to, I can combine these. I get 2x. Okay, so I get 2x cubed minus 4, and denominator is just x cubed plus 4 times x, and there's nothing else you can do. That's our final answer. And now let's take a look at the application of everything we learned in this section. So let's take a look at the word problem. So we have, in a psychological experiment, students were shown a set of nonsense syllables, such as POK, RIZ, DEQ, and so on, and asked to recall them every minute thereafter. The percentage R of T who retain the syllables after T minutes was found to be given by the logarithmic learning model. So T stands for number of minutes. R of T is the name of the function, represent the percentage who retain the syllables after a certain amount of minutes. So our model is given. T is between 1 and 15. And the following question: what percentage of students retain the syllabus after 1 minute? Okay, to solve this, we just take our function and plug in 1. So basically, part A is R evaluate at 1. And that's going to be 80 minus 27 ln of 1. And ln of 1, we know, is 0. So so that's times this equals to 0 from the properties that you have memorized. So then R of 1 equals 80. Anything times 0 is 0, so negative 27 is wiped out, and r of 1 is equal to 80, and it was expressed, it was given to us in percent. Then let's take a look at part B. Part B asks us to find r prime of 2. So it means first take a derivative of our function, then evaluate it at 2. Okay, part B. Okay, so we are looking for r prime of t first. This was 1. Okay, r prime. So take a look at our function. You have 80. When you take a derivative of 80 is 0, right? 0. Then you have constant 27, and then you take a derivative of ln of t, which is 1 over t. Okay, so the derivative just equals to negative 27 over t. Now we evaluate that derivative at 2. Remember, derivative instantaneous rate of change. So what's happening at exactly 2 minutes. All right, so negative 27 divided by 2, and it gives me negative 13.5. So let's interpret that second part, part B. So the results, remember the derivative is instantaneous rate of change. So the result indicate that, so our answer, notice it's negative value. Results indicate that the 2 minutes after students have been shown the syllables, the percentage of them who remember the syllables is shrinking. That's why you have a negative sign in front of the number at the rate of 13.5% per minute. Okay, that's our conclusion. And the following few examples, I want to bring our attention back to the questions that you have seen before even exam 1, is such as find an equation to the line tangent to the graph. So in our case, now we got familiar, or we recalled new functions besides the polynomials, such as natural log and exponential functions. And now we are given functions in terms of these. We have to do the same thing that we did with polynomials. To find equation of the line tangent to the graph, I'm going to use my function given, find derivative, evaluate at a given point, a given x value, find the slope, then take the slope and x. From using the given x, I can find the y because I need a coordinate pair, and use the point and a slope to write equation of the line. So let's go. So y prime, and just so you notice, I have this is the product of two things. So you have to be careful when you differentiate. So I'm gonna use the formula of product. First things, just copy it, times the second prime. I do that just so to remind myself that I'm applying the formula of derivatives properly. Then the second factor times the first factor prime. Okay, and continue with this. Now when I'm differentiating ln of 4x, remember that this it requires a chain rule because it's not just ln of x, it's something with x. Alright, so e to the power of 3x times 1 over 4x times 4, because the derivative of 4x, well, actually, let me write down 4x prime. Just, right now I'm going to write every single step, plus ln of 4x, and then derivative of this, again, it's going to be a chain rule because I have function in exponent. So time e to the 3x times 3x prime. Okay, you can definitely do this in your head at this point, but I just want to make sure because it's a lecture that you have the actual steps written down. Okay, now derivative of 4x is 4, so I have 4 over 4x plus ln of 4x times e to the 3x. Derivative of 3x is 3, and all I need to do is just clean things up a little bit. Let's see. Okay, so what I have, y prime equals e to the 3x. I can bring actually e to the 3x out. That's not a bad idea. What I'm left with here, 1 over x plus 3 times ln of 4x. I just changed the order here, so I brought 3 in front because it's just a factor. Okay, and I brought uh, this factor and this factor out. Okay, that looks good, but we need to still find in an equation. So from y prime, I can get the slope at x equals 1. So evaluating y prime at x equals 1 gives me e to the 3 times 1 is 3 times 1 over 1 is 1 plus 3 times ln of 4 times 1 is 4. Okay, and continue with this. Well, that's actually, this is the exact expression, and I can keep it as slope, or I can put it in my calculator and approximate that. Um, we could, if you put it in a calculator, and I think in your homework exercise they'll want you to not keep it this way but actually approximate. So if you approximate this to 3 decimals, it's gonna be equal to 103.619. Use calculator. Okay, so now I know the slope. um, what is the point? Well, the point, I have to take the original y function and evaluate at x equal 1, not the derivative. So taking the original y function, that's going to be e, 3 to the 1 is 3 times ln of 4 times 1 is 4. Okay, and we also are gonna approximate that. This is an exact value, there's no variables left, and that's approximately equals to 27.844. Again, used calculator. So then let's just recap what I have to continue. Remember, the goal is to write an equation of the line. So I have slope equals 103.619, and I have a point that's made of 1 that was given to us, and we evaluated y function at 1. The y point is 27.844. Okay, so I got a point, that's my x, this is my y. Alright, we can put it into equation and continue. So I'm gonna have y minus 27.844. Well, actually, 5. I think looking at a calculator, I should have rounded to 5 here. So be careful with rounding too early. equals 103.619 times x minus 1. All right, and simplify that by by distributing the slope to each term inside parentheses and then adding 27.8445, and you should get y equals 103.619 x minus 103.619 plus 27.844, and our final answer here is y equals 103.619x minus 75.774. All right, and that's all to it. Just be careful with little steps. You have the help of calculator here, and so hopefully this was a good exercise here. And here's our last problem. The question is the same but different function. Find equation of the line tangent to the graph of so equation is y equals ln of 4x squared minus 7 at x equals 2. And take a look at ln of expression. We are going to be using our chain rule here. So let's do a derivative first. We need the slope at x equal 2, and then we're going to use this y equals ln 4x squared minus 7, evaluate and find y, because what's not given, right, is what is y at x equal 2. So we need that, and we need a slope. And the slope comes from the derivative. So y prime equals, okay, so it's going to be 4x squared minus 7, and on the top, remember, it's 4x squared minus 7 prime, using one of the forms of this chain rule that I've written down at the very beginning of the lesson. It gives me 4 times 2 is 8x on the top, and 4x squared minus 7. This is square. Okay, so we got this. Let's take this derivative, value it at 2, and it gives me 8 times 2 over 4 times 2 square minus 7. And that is going to equal, simplify to 16 over 9, and it's approximately 1.778. Okay, that's the slope. Then when x equal to 2, we evaluate y of 2 equal ln of 4 times 2 squared minus 7 gives me y of 2 equals ln of 4 times 4 16 minus 7 9. Okay, and that's approximately equals to 2.197. All right, so we got a slope equals 1.778 and a point 2 comma 2.197, and we just use our algebra skills from the previous class to convert it to our equation. Y minus 2.197 equals my slope 1.778 times x minus 2. Of course, don't forget to distribute this and then add 2.197. So y is equal to 1.77x minus 2 times 1.778 and then plus 2.197. It comes down to the final answer y equals 1.778 x minus 1.359, and that's the equation tangent to the line at x equals 1, and of course as we figure out at x equals 2 and y equal 2.197.